Right now, this video is racing under the ocean, not through air, not through space, but through a strand of glass thinner than a hair. Glass is the easiest thing on Earth for light to pass through, and somehow it's also the one trap light can't escape. Coming up, why light bends at every surface, the exact angle where glass turns into a perfect mirror, and how one strand of trapped light carries the internet across the sea. One rule: light changes speed when it changes material. In glass, it moves about a third slower than in air. Cross a boundary at an angle and that speed change makes the ray bend. That's refraction. Leaving glass for air, the ray bends away from the perpendicular, and the shallower you aim, the more it leans toward the surface itself. At about 42 degrees for ordinary glass, the exiting ray would have to skim along the surface so it stops leaving. Past that critical angle, the boundary reflects 100% back inside. Not 95% like your bathroom mirror, all of it. In the 1840s, a physicist trapped light inside a curved jet of falling water this way. That's total internal reflection, a perfect mirror made of nothing but an angle. An optical fiber turns that trick into a cable. A glass core carries the light, wrapped in a second glass layer, the cladding, with a slightly lower refractive index. That keeps the perfect mirror around the beam even when the cable bends. And the glass is absurdly pure. If the ocean were this clear, you could see the seabed kilometers down. A pulse travels about 100 kilometers before it even needs a boost. So here's what your internet actually is. A laser flashes billions of times a second, light for 1, dark for 0. Every flash zigzags down the core, bouncing thousands of times a meter and losing almost nothing. Dozens of colors share the same strand, each carrying its own stream. Your click crosses an entire ocean in under a tenth of a second, not as electricity in a wire, but as trapped light in glass. So glass carries light better than anything on Earth, precisely because it can refuse to let it go. Next, how does a microwave heat your food but leave the plate cold? Subscribe so you don't miss it.